Yes, so our results for multiple sequence alignment in tea coffee has been shown here in MView has come, as we can see. Now we will see that which are the templates are closer to our this are having identities with our query sequence, which are more closer. So this is the first one. This is showing 100% identical similarity. The second one is, and our what was the ID of our sequence? Let us check it from here. So it was the first P21678. Here, P21678 was that. Yes, P21678. This regulatory protein CII. So this we can see that P21678. This is our species. This is the very ID, and these are how showing how many percentage identities. So this one is showing IML. This is showing 100% identity. So it is 100% identity. It means that it will we cannot take this very sequence because it will be 100% identical. So it will also be showing it will we will check it for it. So, and the second one is showing P01019. Okay, it is showing 46.5 percentage. So we will take this very sequence, this very sequence. Okay, and the third one is showing this 49 point. We have to keep in mind that the identity percentage should be 30 from 35% onwards. So here we can see that this is showing 46.5%. So the first and the second could be taken. The third one is 49, so this can be taken. The fourth one is again this can be taken and this can be taken last. So let us take the faster sequences of all the these first one, second one, then third one, fourth one, first, second, third, fourth, fifth. These means first, second, then fifth, then 11th, and then 12th. These sequences we have to take as our templates because they are showing good identities, percentage identities. So we'll just take the fastest sequences. So the first sequence is this. First sequence is, let us check what is the identity. A8NVWN. Okay, so let us check here. A8NVW1. Let us copy it from here. Control C and find it here. Yes. Control F. Control V. Yes, this is the sequence. Organism is Coprionopsis cinerea. Okay. So this very sequence, this very faster sequence, we need to copy, and we need to check that whether the structure of is present in uniprot or not, has been deposited or not. So what we'll do is we will go to the or we can open this. We can go back also. We'll go back. Okay, and we'll open that entry. Control F. Enter. This copy, control V. Yes. So we have to take this very sequence. This very sequence. Okay. So let us open this very sequence in a new tab. The sequence is being opening in the new tab. Yes. And we have to take the FASTA format. Already it is there. We have to what we have to do here is we have to see for the its structure. So we will search for its structure here. So here 3D structure databases. So Swiss mod base is there, Swiss model is there. Well, let us search in 3D structure databases mod base whether the structure has been deposited or not. So when we click on mod base, the so this the details about the sequence information, models, detail page, etc. is coming. The sequence is not showing. The structure is not showing. This sequence has not been modeled. Okay, the sequence has not been modeled. Okay, in mod base it has not been modeled. So what we have to do now? We have to go back and how to. We have to go to Interproscan, this database for familiar domains. Interproscan. We discussed a lot about why we will that day why we will go to Interproscan for family and domains. So you should be clear about that. Family and domains. So in family and domains, view protein in Interproscan. So we are going to view the protein in Interproscan. So you can see, yes. So two entries have been are there for this. So let us open these two entries. These are the two entries, the first and the second. So let us open them one by one. These are the two domains of the very protein. So when you will open the, yes, so this family domain will is coming. This is coming, and structures. These are the four domains coming: one, two, three, four, five. Okay. So these are the overlapping entries. Now we have to. The structures are 972 structures have been reported. Okay, so let us open the structure of these domains one by one. So the first domain structure is opening here. So two structures have been reported for this very domain. Let us open these two structures. So two domains are there, have been reported, and for each one of the for one entry, four domains have been reported. As we can see here, uh, these two uh, these two families have been reported, and for this first family, four domains have been reported. This four domains have been reported. Excuse me. So these four domains have been reported, and when one by one we have to open each domain, and we have to find out their structures. So when I opened the first domain, so this very two structures have been reported. So what I will do is I will download the structure, one PYO and one 3EDR. These both of the structures we have to download in the PDB format. So what you can do is you have to copy the structure. You have to copy this one PYO and 3EDR. You have to download it in PDB format, and you have to download it as templates. So you'll go to PDB protein data bank, and there what you will do is you will write the this one PYO, this very name, and one by one you will download both these, one PYO 3EDR, like this you will download. So similarly, I'll show one for one entry. I will show these last entries we got. So for one entry, I'll show you. We have multiple templates, right? So for one template, I'll show you the various domains to be downloaded in PDB format, the various structures. Similarly, you have to download from the multiple sequence alignment for the other structures as well, which are closer, which have closer identities. Like for the first one we are doing, for the second one you have to do by yourself, which is human. The third, fourth, fifth you have to do by yourself, and then we will do all the the domains templates we have got get. Then we will do the advanced modeling section. So first, uh, so I'll stop the video here. Let me perform the sequence, download the sequences, and then I'll show you the files, and then we'll do this step by step process of advanced homology modeling. So thank you for watching.